Well, thank you, Gordon, for those kind remarks. As Gordon mentioned, I'm here to talk about top dressing. And there's a lot of people in the room, obviously, so there's a lot of different interests and perspectives on top dressing. So hopefully I'll touch on your specific interest in the area of top dressing, but certainly we'll have some time at the end. If I don't touch on something that's important or a question you have, please feel free to ask, because we'll have time at the end for questioning. And if there's something really burning as I go through the talk, raise your hand and we'll try to address those things, because there's a lot of different things to think about with top dressing. Top dressing is considered as a desirable practice. We do it for a number of different reasons. Uniformity of the surface, firmness of the surface, thatch modification, etc. But one of the things to think about is, how many fully understand all the various pros and cons of top dressing? And, what are all your options? Should you be doing all of them, some of them? So hopefully this presentation is designed in a way to kind of address those kinds of questions of how well do we understand this practice and is it right for us. To do a good top dressing program, you have to have a good sound knowledge about what you're doing, and one of the first things you need to think about is it economically feasible. It's really easy for someone like me to stand up in front of an audience and say, you got to be top dressing, it's the latest and greatest, you ought to be doing it. But the reality is it's not a cheap practice, especially depending on the program that you embark on. And so we'll touch on some of the things that affect the feasibility from an economic standpoint. What are the logistics and the agronomics behind what your program is trying to do? We'll touch on that. Logistics of delivering, storing, and applying large volumes of material. This is something that you really need to think about if you're going to embark on a top dressing program. This is not a trivial thing. Storing, delivering, managing large bulk quantities of material are very challenging to do, especially if you're a lower budget operation. And the agronomic reasoning behind what kind of materials you're going to select to apply fields, what's the timing, what is the frequency of those applications, and what are your quantities. And I think some people don't have necessarily a full grasp of what the quantities need to be to achieve certain objectives, and so we'll touch on that topic as well. So let's start off with the economic feasibility. Before you embark on top dressing, you must thoroughly look at equipment, materials, and labor. These things can add up rather quickly and get quite expensive, especially if you're going to have a very aggressive top dressing program. In terms of equipment, things that you need to have to do this practice efficiently and effectively, utility vehicles, tractors, loaders, spreaders, drags, aerators. These are all things that are very, very helpful and beneficial in a program. If you lack some of this kind of equipment, you're going to struggle with doing the job efficiently and effectively. And so you want to make sure that you look at your inventory of equipment and make sure that you're not shorted on that aspect. Size of equipment is really important. If you're doing a lot of spot top dressing, goal mouths, worn out areas, a walk-behind machine is going to be great for that kind of purpose. But if you're trying to top dress 10, 20 acres, you have a really multi-field complex where you're trying to address many, many acres of turf, then you need a totally different type of machine, and obviously the cost of that goes up as well. So making sure that you're not trying to do 10 acres with a walk-behind top dresser is something you want to think about when you're considering top dressing. And if you don't have the right equipment, do you have the ability to acquire those resources to make the job work for your scope of work? Materials. We'll get into more details about this, but obviously the way I'm going to teach it and approach it is you're going to select your materials after you identify what your agronomic needs are. And we'll talk about the details of this in a little bit here. But it's really important to match what you're doing with what your objectives are. What are you trying to achieve? And then once you figure that out, then you can start looking for the right materials and start having a conversation about cost of those materials. And so some materials can be relatively expensive, but some can be also quite expensive depending on what you're looking for. And then the other factor, depending on where you're at across the country, shipping can be a small cost or it can be a very large cost. So if you're not close to a source of material that you want to use, you have to factor in that they're going to have to ship it, and that's going to elevate the cost. So you know, the product itself might be, $20 a ton, but it might be $20 worth a ton of shipping on top of that to get the material that you want for your facility. So those are some factors you need to think about if you're considering going into a top dressing program, and they aren't necessarily trivial. So in terms of choosing a material, I'm going to try to keep this as simple and straightforward as possible. It really breaks down to what kind of root zone that you're top dressing. So are you looking at sand-dominated root zones? Or are you looking at native or loamy or silty soils? So people use different terms to describe what I call fine-textured soils. But those native soils that you have on your property, not highly modified, if modified at all, that's the first thing you need to decide is what are you trying to manage here? And so we'll go into the details of that. Let's start off with the native, loamy, silty soils. What you're typically trying to achieve with top dressing these kinds of soils is you need to improve the structure of that soil or keep the structure of the soil. You may have a really well-structured soil to begin with, but you're trying to maintain it and manage it. And so finer texture soils, those soils that have some silt and clay, significant quantities of that, the way you try to make those be well aerated, have good root development in those soils is you have to build structure in those soils. And one of the ways, the primary way to do that is to add organic matter to those soils. The organic matter addition to the soils stimulates a lot of biological activity, and it produces substances that essentially start sticking the soil particles together. So you get the sand grains, the silt particles, the clay particles to aggregate or form some people call them clods, but clods is not the scientific term. The scientific term is an aggregate. And these are the building blocks of structure in those soils. So you want your soils to build structure. The reason we don't have this objective in sands is sands are very difficult to form aggregate structure, but with silty soils, loamy soils, it's possible to do. And so this is where adding organic matter is very beneficial. So how do you add organic matter to soils? Where do you get this material? In farming systems, there's a lot of livestock activity, plant production, plant waste, residues. And so in farming, these kinds of options are very viable, but in a sports field complex, you don't necessarily have a waste pile of plant residues or organic materials to use, so that you have to go out and find and source a high-quality material. And this is not a trivial task because compost, unlike buying fertilizers, you don't have guaranteed analysis to say, yep, this meets what you're looking for, here it is. There are tests you can run on compost. You can measure characteristics and qualities. I'll show you some slides of that kind of information in a bit. But the point I want to make here is there isn't really a nice, easy product like you go to buy a 20-0-10 fertilizer, you know it's a 20-0-10 because it's guaranteed. It gives you those numbers. Whereas in a compost, you can run into some really bad, awful compost, and you can have really high-quality compost. So you have to do a little bit of homework to understand what you're working with when you're using organic matter and make sure you source out a very high-quality material because you don't want to be like some of the people I've unfortunately run across who go out and get, quote, a compost, and they spread it on their grass, and it causes problems. It can be salty. It can be a lot of fast-acting, salty material that will burn the turf. It can be kind of foul-smelling, and those are all things you don't want to be spreading on your grass. I put a resource here for you to look at. Penn State has a nice fact sheet online about compost and compost selection. And so I'm not going to have the time to cover every aspect of that, but I do want to point out there is online this really good resource that I've used a number of times to prepare presentations. And so here's some of the characteristics you want to look for if you're going to use compost to top-dressed fields, these native, silty, loamy soils. Color is pretty simple. You want it to be brown to kind of blackish color. You also want it to be relatively small in size. You don't want big chunks of material because that's going to be very difficult to incorporate down into turf. It's going to sit up on top and be objectionable, obviously, if people are trying to play the turf. So you want it to be screened in relatively small material, going through a 3/8-inch screen or quarter-inch screen kind of stuff. I mentioned earlier these things can be foul if they're bad, and so you're looking for an earthy smell. It should smell like earth, but if it smells putrid, rotten egg smell, that's a bad sign. I wouldn't ever apply a material like that to turf. Moisture content, it doesn't need to be bone dry, and in fact at these percentages, 30%, it'll feel somewhat dry, but there'll be some moisture in it. You don't want it to be sopping wet because it'll be very, very difficult to spread. It'll be a nuisance. And actually, if it gets too wet, it can turn putrid on you and get anaerobic. Organic matter percentage, this can be quite variable depending on the compost source, but you want something that's at least 30% organic matter. Otherwise, essentially, you're just applying a lot of mineral material to the soil. And you're not achieving what you want. So this organic matter percentage, higher is better, but I wouldn't accept anything less than 30% if I'm using it to top-dress sports fields. This here is a little bit complex, this carbon to nitrogen ratio issue. This is an important parameter to make sure that nitrogen is available to your turf. And once you start getting ratios that are above 30-to-1, so 30 parts carbon to 1 part nitrogen, what's going to happen is that's going to be a great material to stimulate biological activity. The bacteria, the fungi, et cetera, really get activated, start growing. But that's bad if there isn't enough nitrogen in the system because those microbes need nitrogen to do their thing as well as the plants, and they'll start starving the plants for nitrogen. So if you get something that's too rich in carbon, that's good for the soil in the long run, but in the short run, what you're going to see is nitrogen starvation of your turf plants. You can partially overcome that by adding more nitrogen fertilizer, but you don't really want to do that to yourself. You're just creating more work, and you're going to struggle to find out how much nitrogen to apply if this ratio is too high. Phosphorus will be typically present in compost, and this is not a very high percentage, 0.2%. pH should be somewhere where you find it acceptable for turf. So typically in the east we recommend 6.5, 6.7. I'm sure some of you are from parts of the country where you're 7 or higher naturally, but you don't want to get a compost material that has some really strange, really low pH or really high pH. So somewhere in that 6 to 8 range is considered to be acceptable, and closer to what you want to manage your turf is better. Metal content can be an issue in some composts, and these are determined by state and federal agencies. Soluble salts, I mentioned that. Some materials can come back with high salt content, and you certainly want to stay away from those because salts can burn your grass. And if it's high enough, it can create a longer-term problem until those salts might be able to be leached out of the profile. But as I said earlier, the difficulty with compost is we have these standards, quote unquote, and we recommend these to people to use in buying a good compost to use on their sports field. The difficulty is it's not like the fertilizer industry. You can't go out and buy, a 10-0-10 compost that's got a guaranteed analysis. You have to work with a company that can provide you this data to make sure the material you're using is a good quality and excellent source. And then hopefully it's a consistent material, because if you're embarking on this program, you're probably going to want to do it more than once. And so you need to find a source that is reliable, that you can find month to month, year to year, and that kind of thing. So that would be the difficulty with using organic matter, is sourcing the material. It's also a challenge with sands, which we'll get to in a little bit, but it's a little bit easier in some respects than compost. So let's talk about sands relative to these native soils. Small amounts of sand top dressed over the top of a silty soil, or a loamy soil is really not going to do much for you. It feels good. We would like it to do more than it probably does. And in fact, small quantities of sand on top of these soils may actually hurt structure. And this is because you're essentially filling up whatever pore space is in that native soil with sand grains. And sands are solid grains of mineral. They don't have any porosity to speak of. And essentially, a few sand grains in a loamy soil is just plugging it up. And not necessarily going to be something that it destroys the soil, but it's certainly not going to hurt or help. And like I said, in some cases, it may hurt. Well, the thing you have to understand about top dressing with sands is you have to apply enough sand so that the sand particles are bridging or touching each other. And essentially, you're building a scaffolding system out of sand grains in your soil profile. And then the space between the sand grains is the aeration porosity, the porosity that you're trying to achieve by adding high sand. So you have to use large amounts of sand to be effective if you're going to embark on a sand top dressing program. A little bit of sand isn't necessarily going to do a whole lot for you. In fact, might actually hurt. So where do we use sands? Sand-dominated soils. And so let's talk about that. The goal that you're trying to achieve with sand top dressing is you're trying to maintain this layer of essentially a nearly pure sand layer at the surface. Now, there's going to be grass growing in it. You're going to have some thatch in it. But essentially, you're making the decision, I am going to manage this turf to be growing in a sand surface profile. Situations that fit this kind of philosophy, this approach, are number one, sand-dominated root zone. So you got 10, 12 inches of a sand profile, maybe sitting over a drainage system, really high-end construction type field. Or it might be a sand cap field, and we'll talk a little bit more about that. Or you are managing a native soil to become a sand cap field. And so you can see where I'm going with this. If you choose to go with sand, you're making a commitment to basically transition. You're either in a sand-based system to begin with, or you're going to transition to become predominantly sand-based. So why do we use sands, and why do we top dress with sands? Well, what we're trying to manage against is that mud bowl event. You know, that Friday night football game when it's raining, it's really wet. Those are conditions where if they play the game, they're probably going to ruin the surface, or at least part of the surface. Maybe not the entire field, but the midsection of the field. The goal moss on a soccer field are going to just be utterly devastated under those kinds of conditions. And that's really why we use sands. There isn't anything more to it than that. This is the primary reason why you want to use a sand-based system. There are some cautions about going this direction that you need to think about. If you're considering going the route of sand-based irrigation, it's sand, so it doesn't hold on a lot of water. It's drouthy. You need to have a good irrigation system in place, because if you achieve the goal of becoming sand-dominated, water is going to be needed when it's not coming down naturally. Core harvesting equipment might be something you want to think about, especially if you're going to pull cores. You want to avoid potentially pulling up soil that contains silt and clay, having it sit on top and start to contaminate that sand layer. A little bit of soil isn't the end of the world, but if you do a real aggressive job of core aerating and get a lot of soil up on top and you don't remove it, you have the potential of offsetting what you're trying to achieve, which is to develop a well-aerated, fast-draining, dry, sandy surface. And the other thing to think about is over time, this won't happen with 1 or 2 top dressings, but over the period of 3, 4, 5 years, if you're really aggressive, which you should be if you're going this route, that surface is going to become the dominant growing medium. And so that's going to have lower fertility in it. And so you'll see that there'll be some subtle changes, in some cases drastic changes, in how you have to fertilize that surface. So you have to be aware that your fertility program is likely to change, and it will be much less intolerant of low and insufficient amounts of nutrient applications. So sands. How do you select a sand? Well, the primary thing you want to think about with a sand is what is its size. And its size is classified in a number of ways, and I'm showing you several different ways to think about it. Some people think about sieve numbers. So across the top here, each one of these columns is defined by what's passing a sieve in a laboratory. And so this number 10 sieve is a 2 millimeter sieve, and so what passes this sieve and stops on the number 18 sieve, which is a 1 millimeter sieve, those particles are considered very coarse sand. Anything above 2 millimeters would be considered gravel, and gravel can be classified in a couple of different sizes as well. So then as we go to the right here, this is the 1 to 1/2 millimeter size, or coarse sand particles, the 1/2 to 1/4 millimeter size. These are medium, 1/4 to 0.15. Some people use 0.1. In this case, I'm showing you 0.15. That would represent the fine sand, and then the very fine sand is between 0.15 and 0.05, and that's defined by the number 270 sieve. So the 0.05, that's that sieve right there. And many of you probably are familiar with the USGA putting green construction, and that is a good basis to evaluate sands from. I think that we can be have a little bit more leeway in the sports turf industry if we'd like. But here's the one standard that is out there, and many people are familiar with it. This is the construction specification, where they want no more than 10% very coarse sand. These two particle sizes, coarse and medium, they recommend having a minimum of 60 or more in the sand. And then the finer particles, the fine and very fine, are restricted. With the fines, they allow up to 20% or less, and then with the very fine sand, it's 5% or less. So this is a good standard to work from. I don't know that in the sports turf industry we have to be quite this rigid. You can get finer sands that have maybe 25% sand in the fine range that work quite well for sports fields. We don't have to be quite as dry as people want putting greens to be in the sports field area. However, if that is your preference to have a dry, very dry surface, then I would try to adhere to these standards and have as little of this fine and very fine sand in it as possible. If your criteria is you want fast draining and very dry surfaces, the sand quantity, the sand sizes you want in a sand are this coarse and medium. These are the two sizes that give you the aeration, the water flow that you're looking for. So that's kind of how to look at sand size distribution. You really want to be working with coarse and medium. The drier and faster draining you want it to be. If you're willing to allow moisture retention, a little wetter surface, then you can increase these quantities of fine sand accordingly. Some other things that are probably not quite as important with selecting sands to think about are what's the particle shape. In my world, we typically are working with what they call sub-rounded sands, but if they get too rounded and too spherical, they're like little ball bearings, and the sands won't have as much stability because they roll around, they move very easily. And on the other end of the spectrum are what they call sharp sands, which are very angular, and they will lock together and form a very firm, hard, stiff surface. So the biggest thing you want to worry about or be concerned about in selecting the sand is the particle size distribution, but you may be interested in the shape of the sand. And for those of you who live in more remote areas across the country, selection becomes very difficult because you're challenged to find the exact sand that you're looking for with the right qualities. And once you do find it, unfortunately, sometimes it's very far away and you have to ship it in. And that's where that shipping cost adds to a sand program in certain parts of the country. I'm in New Jersey, and we're benefited from having many sand suppliers within, an hour or two drive of where I am. And that's a fortunate thing. There are parts in the country where that's not the norm, though. If you're interested in a sand camp field, I'm not going to talk a great deal about it, but there is a good resource online offered by Michigan State University that talks about a built-up sand cap athletic field system. If you're not familiar with that, I'll just kind of briefly overview what it is. Essentially, what you're trying to do is take your native soil and you're trying to cover it with basically sand top dressing. And some people will also put drain to kind of link the sandy surface to a drain trench, a bypass drain, slit drain. People call these by different terms. But I have seen fields with just capping with sand works quite well by itself. But if you want that extra drainage, faster drainage, adding the drain system works. But essentially, what you're going to do over time with a top dressing program is build that sand cap up and try to get that to be, a couple inches deep to give you the characteristics you're looking for in the surface of that. But again, if you want to read more about it, I'll refer you to the website here at Michigan State. So if you just Google sand cap fields, MSU, their PDF will come up very quickly for you. So when you're using sand-based top dressing, you need to think about timing. How often am I going to do this, and how aggressive am I going to be about applying this material? And what you're trying to avoid is developing layers like you see in this slide. Layering your profile isn't necessarily going to be a death sentence to you, but very often when you see problems with top dressing programs, they're related to inconsistencies in how that top dressing is being applied. And so what you would rather see is a much more uniform profile where the sand and the thatch that develops in the grass is better mixed so that you don't have layers of thatch, layers of sand, layers of thatch, layers of sand. And so what is the guiding principle? Essentially, you're trying to match the development of the turf. Thatch doesn't grow down here. The thatch that's at this point in the profile happened several years ago probably. Where thatch develops is at the surface. So thatch is developing in response to the grass that's growing on top of the fields, and it develops at the surface. And so this is the youngest developing thatch right here. And so what you have to do is think about how fast is my turf developing thatch, and I want to apply the top dressing in a way that matches that development so that I keep the thatch evenly mixed with the top dressing material that I'm applying here. Generally speaking, the lighter you apply the material and the more often you do it, the better mixing and better incorporation is going to be. But that comes with an economic cost, right? Who has the time to go out and top dress once a week at very light rates? And so more often than not, you're probably going to be looking at monthly programs or every 6 weeks because that's going to be what's economically feasible. Some of you in the room may have the resources to do, every week or two applications at very light rates. So you have to kind of find out what works for you in your facility. What's going to be a good balance between avoiding this but not being so expensive that it's ridiculous for your program. So let's talk about quantities of sand then. And I've got this listed in a number of different ways. So each one of these columns is a different set of units. You got inches, tons per acre, pounds per thousand, cubic yards per acre, cubic feet per 1,000 square feet. But each one of these rows is essentially the same quantity of material. It's just expressed in a different way because each of us probably thinks about how we're applying top dressing in a different way. I often think in cubic feet per 1,000, but some people think in cubic yards per acre or pounds per 1,000 or tons per acre, and some people think about what's the depth of sand that I'm applying. And so if you're trying to build up, a 2-inch layer or more of a sand cap on a native soil, and you're applying basically one of these levels of top dressing, you're not even doing a tenth. Well, technically, if you round this one up, this is a tenth of an inch. This 8 cubic feet per thousand, or basically 17 tons per acre, that's a tenth of an inch of sand. So if you're trying to build up 2 inches at a tenth of an inch a time, you do the math, how many applications? You got to make 20 applications to get a 2-inch layer. So 20 applications, you're going to be able to do 20 applications in a year, 2 years, 3 years. So, this issue of frequency of application, quantity of application is what I'm trying to get across in this slide to give you a context of what you need to be applying to be able to achieve your objectives. And if you're trying to go faster, obviously, this 16 cubic feet per thousand or 35 tons per acre is putting out about 2/10 of an inch per application. Other thing to think about when you're applying sands, especially higher quantities, if you're trying to go fast at very high quantities, you want that stuff to filter into the turf. So you want to think about how dry the turf is, because if it has any moisture in the grass, it's not going to want to filter in. It's going to want to layer on you. So let me back up to this slide. If you're trying to avoid these kind of heavy layers, you want that to infiltrate into the thatch better. You need to keep the system relatively dry while you're doing it so the sand has a chance to sift into the thatch. So applying it when the turf is dry, if you can have access to dry sand or relatively dry sand, those are all factors that are going to help that sand infiltrate and hopefully not form a bridged layer on top of the thatch as you apply it. So that's really important for these much higher rates, is using those when the turf is pretty dry and the sand itself hopefully is relatively dry. If you're trying to build that cap more rapidly, as we talked about as the guiding principle behind how much you apply and when you apply it, you're trying to match the growth rate of the grass. Well, one thing you can do to stimulate the process is to fertilize a bit more aggressively. I'm not telling you to go out with 10 pounds per thousand or anything like that. But if you're only fertilizing your fields at 1 pound or 2 per thousand, just getting it up to 2 or 3 is going to help the grass develop more quickly, which will allow you to top dress more and more often. So if you want to speed up the process, fertilizing a bit more will help speed it up. It's not necessarily going to double or triple what you can do, but it's certainly going to increase how aggressively you can build up that sand cap over time. Labor is another issue. Obviously, you can see what we're talking about is if you're one person or 2 people, you're talking about a lot of man hours spread over just 1 or 2 individuals. So do you have a crew to help implement these programs that address what you're trying to do? So you need to think about the labor part of the economics of this top dressing practice. Where you need labor to help make these processes more effective is you're going to have to transfer materials out of some kind of stockpile, get it out to the field, get it into the spreader, get it on the field, and that process of going back and forth between the top dressing stockpile and into the spreader and onto the field is something that you want to give some thought to, because that is rather cumbersome, it's rather bulky, and it's a lot for one person to do. It's a lot for 2 people to do. Some things to think about. This isn't for everybody, but for those of you who aren't aware that this kind of technology is out there, you should think about it. It may be something that you can ultimately afford. Maybe it can't be, but I think it's interesting that I think it's important that you understand these things are out there. This is what they call a sand silo. This is for storing dry sand, and obviously the sand's up there, and you drive underneath, you dump it out the bottom. It really takes a 2 or 3 person job and cuts down the labor requirements quite a bit. Here's kind of the Cadillac of them all. This is how the system works. The truck comes in with dry sand and then it pumps it up in the silo, and here you can see the equipment for storing or for transporting and spreading the sand underneath. Obviously expensive, not something that's cheap. Not everybody can afford it, but this is what a lot of operations who do a lot of top dressing gravitate to, because this helps with the labor requirement. You're taking some capital expenditure and you're replacing labor with it. You don't need quite as many people to load and transport the material out to the site for top dressing.
What kind of capacity does something like that have?
You can get various sizes of them, but we have one at our research farm, and don't quote me, but I think it's over 20 tons you can store in it. So you can get various sizes. I think there's 2 or 3 sizes that you can get for that. I'm not sure of this particular one here, what size this is. Incorporating the top dressing material, obviously if you have small areas, hand spreading it, raking it in is certainly feasible, but once you get beyond a few thousand square feet, it turns into a mighty chore for people to do hand raking. So there's various implements and tools, drag mats. Here's kind of a spring tooth rake that are good for stirring and incorporating materials into the surface. So whatever tools you like and work for you is what I encourage. There's a lot of different creative ways that people have thought of to drag in these materials, but it's really useful to help get material to sift into your thatch down towards the root system. So getting material incorporated down into the native soils is what I want to kind of take a couple minutes to talk about here. When you're working with these finer textured soils, whether they be loams or silt loams, things like that, trying to get your top dressing mixed into the soil is going to help that process of building structure. And so let's talk a little bit about that. When you're applying compost, the strategy is to apply a light layer, maybe a 1/4 inch. You can go lighter if you want, but keep in mind the lighter you go, the more often you're going to have to do it to achieve the same benefits. So somewhere around a 1/4 inch or less is applied to the field, and then it would be ideal if you could incorporate that with an aerator. So typically what's recommended is you go out with an aerator equipped with hollow tines, you pull up those cores, and then you drag behind it. And some people will actually put the drag on the back of the aerator so that they only have to go over the field once with one piece of equipment. But some people will drag it with a separate power unit, so it's 2 passes over the field. Just a suggestion on how to maybe potentially economize on times over the field. Essentially, the drag mat is there to break up the cores and help mix it with the compost, drag some of it into the holes, and get that mixing process going for you. Soil organisms will do that. Things like earthworms, ants, other critters in the soil will help to stir that compost and soil over time. So we're just trying to do it mechanically ourselves to get the process kind of jump-started and get it going, but some mixing is always good. These kinds of practices are best performed in the spring or the fall when the temperatures are cooler for cool season grasses. That's the region of the world I'm from, when the grass is actively growing. It's a little bit different for warm season grasses where you have more vigorous growth in the summertime. So basically when the grass is more actively growing is when you really want to be doing these practices. Then you have the challenge of fitting it into your use patterns, what's scheduled for that week, that month, and whether it matches up. But that's the challenges of sports field management, is to fit these practices in when the schedule allows it. But you don't want to be doing this kind of operation when the grass is stressed, because you're stressing the grass by aerating it, top dressing it, dragging it, and you don't want to add to heat stress or drought stress, things like that. Some other logistical factors to think about with programs is equipment, storage, and if you can put it under cover, it's going to last longer. You won't have to replace it quite as frequently, so that's a key because you're going to buy several pieces of equipment for a top dressing program. And you also want to think about if you're stockpiling your top dressing on site, can you put it under cover of some kind? I showed a sand silo for dry sand a little bit ago, but you don't have to be quite that expensive. Basically, one of these bins under cover can do a pretty good job of protecting material. You reduce your losses. Wind, storms can move the stuff around. Prevent weed seed contamination from getting into your top dressing if it sits for a long period of time. And also putting it under cover can help out in making sure it's a consistent moisture, so it's not too dry, not too wet, which will basically make spreading more difficult. You need to think about time of delivery if you're not going to stockpile the material. So you have to think of the logistics. Where can I store my stockpiles, and is that convenient to where I need to spread it? Is it going to be objectionable to anybody else that uses the property if this pile sits there for a day or two or a week? So if you're not going to have a consistent stockpile on site, you need to think about when they deliver it, where they're going to dump it, basically. Material handling, moist or dry material is going to be a little easier to spread and incorporate and handle. And loading and transporting of that around site is going to be a lot better if it's on the drier side than the wetter side. And then the last logistical factor to think about is, especially if you're going to do a big project and it takes a handful or two hands full of people to get it done, you're going to need to coordinate the availability of all the personnel needed for those labor-intensive activities. And so scheduling people, managing people's schedules is critical to being successful at doing this, especially when you're doing it multiple times per year. It's a task that needs some scheduling attention on the human side as well. Those are my prepared comments for this morning's talk on top dressing. Certainly appreciate your attendance.